Then we're going to go down. All right. All right, this is what I said would be there in some form. Let me get the key out here. Problem number 1. What was that? Those are graphing exponential and logarithmic functions, right? So you get your right. So we're down here somewhere. All right, logarithmic functions, properties. Oh, how's that? Logarithmic properties, graphs, right? Critical to have a plan. Every single graph we did in here, you start with a plan. You start with the library of functions. Those are a set of functions whose graph you know. I gotta do those are a set of functions whose graph you know. You got to start with the right function. So if it's an exponential problem, don't start with y equals x squared. Right. Look at the examples we did in class. In fact, that is probably my most frequent comment on tests, because the examples we did in class will show you how to do that. If you see that on the test, the examples in class will show you exactly what needs to be done on that kind of problem. And if you have trouble with that, come see me. Or I always like to mention, you can see the go to the Edge Center. You got the you got tutors there. Get together in study groups. But anyway, so you have in both 1 and 2, you just absolutely have to start. You have to have a plan, and you have to start with the right function. And that's from the library of functions. And so if you haven't internalized that library of functions, that's like saying I don't know north, south, east, and west. Right? You're not going to get very far. The second thing is you're going to turn the function that is in your library of functions, your starting point, you're going to turn it to the function you try to graph. And you're going to do that by one transformation at a time. I know some people try to do 2. You can. It is possible. But I'm telling you, that is a very common place that people mess up, is trying to do more than one transformation in a step. Do one transformation at a time. It does a predictable thing to the graph. And so on your graph, you are taking your original graph and you're shifting it and you're flipping it, right? Also, I recommend doing stretches and compressions and reflections first and shifts second. Shifts second. All right, that's problems 1 and 2. Oh, yes. Okay, these are right here. Solving logarithmic and exponential equations. You have one logarithmic, one exponential. The key with the exponential one, what was the key we did almost the whole time? Get equal bases on each side. Get the same base on each side. Bunch of problems we did. Right? So look at the class notes. They're all online. Even days I didn't turn on, I forget to turn on the camera or the recording, I always got the class notes up there. Right? And plus there's ones in your book. The advantage of the book, have I mentioned that the book is the most underutilized resource? I think I have, right? Yeah. In the book, you have explanation along with the solution. On the videos, you have explanation along with the solution. Right? So if you look at the date, for example, you find the class notes of an example you want to hear more about. Look at the date on that and go find the video for that class, and you will hear that problem presented. That may help you, right? So that's number 4. Number 3, you need to start off with the definition of a logarithm, right? Y equals log base A of X means right? Right? So y is the power to which you must raise the base to equal what you're taking the log of. That is the key to start number 3. That's the key to start number 3. Then you're going to do equal bases on each side. Once you do this on number 3, it becomes a exponential problem, which is why we did logarithms after exponentials. Number 5, let's see here. This was finding and graphing it, well, finding inverse functions, finding the range and domain, right? Finding the range and domain. So how do you find an inverse of a function? You first swap x and y, and then you solve for y. Okay. Now, a common mistake I saw, and I don't know if I've seen this in the past like I did here, but a common mistake I saw is that some people would write, they would take the function, and wherever there was an x, they would put a y. But they wouldn't set it equal to anything. They wouldn't set it equal to anything. So when you substitute x and y, you're substituting it on both sides of the equation. And so you're going to wind up with the first step is switch x and y. The second step is solve for y. In order to solve for y, you have to do what? You have to have two sides to an equation to solve for something. Right. So again, see the class examples. We did 2 or 3 of these. All right, and then range and domain. We already talked about finding the range and domain of functions. That was part B. That was part B. Keep in mind, range and domain are sets. So saying x is greater than -1, well, that's a partial credit answer if it's quote correct. But you have to express that as a set. Range and domain are sets. All right. Next, down here we have one thing that wasn't on there, I could put on there. I didn't have any change of base. All right. I did not put any change of base on there. But properties of logarithms, we certainly had. Right. We had that part. We had this part. Compound interest is where we're at now on the last page. If you did not have a calculator, things got gnarly because you needed a calculator. You didn't even need a graphing calculator on this one. You just needed a calculator to know how to use it, right? But it couldn't be your phone, right? But these are 2 compound interest problems. We did them in class. Some things I would say are this. Number 1, what kind of compound interest is it talking about? Is it even, talking about compound interest? Is it even talking about compound interest? Or is it talking about simple interest? So if it's talking about compound interest and you use the formula for simple interest, you're off to a bad start. And so on the on the bottom of the next page, I gave you the formulas like I said I would. But I also said you needed to know which formula to use. And that only comes with doing problems at home. That only comes with outside preparation. It only comes with reps on the machine, right? If you are guessing which one to use, you're probably guessing the wrong formula. And many, I saw many papers where it was the wrong formula, wrong kind of interest from the start. Right? So anyway, so in each of these problems, ask yourself, number 1, is it talking about compound interest or simple interest? Number 2, is it asking you for a present amount or a future amount? Is it asking for A or P? Number 3, what kind of, if it is compound interest, what kind of compound interest is it talking about? Is it continuously compounded interest? Is it interest compounded monthly? Is it compounded daily, yearly? What is it? And all of those things, if you look at especially look at the notes, we did several of each kind of these. Several, not one. We did several. All right. And so you identify what what you're looking for, A or P. Then you identify the problem. What is the other one? If it's asking you for the future amount, it's going to give you in some form the present amount. How frequently is it compounded? Is it compounded daily? If it's compounded at all, is it compounded daily, yearly? Right. So those are some hints on some help on, hopefully helps on number 6 and 7. And that is here. Exponential growth and decay. That is number 8. Now, again, this goes back. If we spend several days covering something in class, you know that's going to be there. Especially when I get up here and make a fool out of myself telling you it's going to be there. If I tell you it's going to be there, and I say, we're covering this for 2 or 3 days, that's a week. 3 class days is a week. Right? So if a lot of time is spent in class, like on exponential growth and decay. We did 2 problems. One was exponential growth. One was exponential decay. You had a homework on that, right? And by the way, the window's closed for chapter 4 homework. All right. The test day is the last day for chapter 4 homework. And the reason why is the purpose of homework is to prepare you for the test, right? But anyway, exponential growth and decay, you are going to use the fundamental equation is A equals A0 e to the k t. And you've got to identify in the problem if you're given any of these. And then with that, you must find 2 things. Number 1, you got to find A0. Number 2, you need to find K. And there's some algebra to be done there. There's some algebra to be done there, which is why that first part is worth more points than, say, the second part. The second part is relatively easy, part B, if you have the first part. And by the way, if you made a mistake in the first part, your answers to part B and C have to be consistent with part A. So in the first part, if you made a mistake, but you got some kind of equation for your growth model, even if it's wrong, but you use that equation correctly in parts B and C, I gave you full credit for parts B and C. But if you exercise those skills, so if you did the skills based on a mistake you made in A, you missed points in A, but I don't want things in A to trickle down to B and C. Now, if you have either A almost blank, or if you have total nonsense in A, you're going to miss parts B and C. If you have just whatever in A. If you don't come up with an equation that you're going to use correctly in parts B and C, you're going to miss parts B and C even if you miss A. Okay. But if you correctly use the equation, the function, the growth model that you arrived at in A, if you correctly use that in parts B and C, even if the part A was wrong, you got full credits for part B and C, even though your answers are going to be very wrong. You got very wrong answers in parts B and C, but they're correct given your model. So I don't want to deduct twice for the same mistake. You make a mistake in A, you're not penalized for that mistake in B and C, unless A is gibberish. All right. If A, it makes no sense and it's just you're waving the white flag basically, right? Then parts B and C you're not going to get credit for. All right. Now, all right, today is Friday. Okay. You have until Wednesday, and that is the 21st. You have till 4 p.m., Wednesday the 21st, to stop by my office and make corrections on this exam to earn points back. Right? You have until Wednesday, okay? Now, Monday night is Spark. That's a great time to get help, but so are my office hours, right? Office hours right there. Yeah, and by the way, office hours are on, they're on Canvas. They're in the course guide. So if you have your notebook with you of all the notes for the class, including the course guide, those office hours are in there. Also, I want to take this time to remind you about the date of the final. This final exam schedule is on Canvas. This is for all your classes, by the way. I have highlighted here my classes, right? And so a Monday, Wednesday, Friday, 9 a.m. class has an exam Thursday, April 29th at 9 a.m. here. So Thursday, April 29th, 9 a.m. Right here. Let me just emphasize also, good time while I'm thinking about it. We got Spark session next Monday in 3 days. We have a Spark session the following Monday, 10 days. All right, I'll be at both, unless I am providentially hindered. But I've been at all of them so far. I'll be at. I'm planning on being at both of those. Also, on Tuesday of quote finals week, Tuesday of finals week, there is usually spring semester. I don't know if there's going to be one. That's not my call. There is usually a ice cream social in the CAF. And since they're having like almost normal meals in the CAF, I think there's probably going to be this ice cream social. But I don't know. That's not up to me, right? Listen to the communication you get from Jolene Herzog, her office, and from student development, all right? They make that call, not me. But if there is one, and there probably will be, but I don't know. If there is one, I will be there. They usually start at 10 p.m. So me, the cranky old man who's usually in bed by 10 p.m., I will be at the ice cream social, and I set up shop usually on the north side of the CAF, which is the side that is toward the building formerly known as the library, right? And we grab some tables there. I'm usually a few minutes early. Like if it starts at 10, I'm usually there at like 9:30, 9:45, somewhere in there. We get going. People stretch out their books. They spread out their books. They get in groups by classes. I'll probably have somebody from all of my classes there. That's usually the case. Calc and statistics always come heavy. Those folks are always there. Anyway, I want to help you do the best you can on your final. And last, you're allowed to weigh your final 25, 50, or 75% of your course grade. 25, 50, or 75% of your whole course grade. You can pick the amount on the exam. Okay? So after you take the exam, at the bottom of the exam, there is how much do you want it weighed? 25, 50, or 75%. You check the box. Now, if you really want to weigh your grade, you need to prepare yourself to score higher than you've been scoring. That way, you weigh it heavier, your grade goes up. And just by the way, if somebody scores the same on the final or about the same on the final as you have during the course of the semester, it's not going to affect your grade. It doesn't matter how much you weigh it, right? It doesn't matter how much you weigh it. So I will take care of weighing your grade. You may see a strange entry in Moodle. I said Moodle, Canvas. And that will be a final exam adjustment. And it adjusts your grade for how much you weighed your final. I will take care of that. I know how much to enter there. I know how to figure that out, right? But I will make sure. Now, if you score the same as you did during the semester, if someone's got a 65 coming into the final and they score 68, your grade isn't changing. I won't even bother weighting that because it won't matter what I weigh it, right? All right. And while we're recording, let me just emphasize again. I'm about to go around and collect the exams, okay? I'm going to hand you a final exam review. This is something for you to do. You can consider this a study guide. As close as you're going to get from me, all right? A study guide. This, again, is not enough to prepare you for the final. You use this to determine whether you have already adequately prepared for the final. So you study for the final as if you're ready to take it, then take this. And this has it has answers. It doesn't have solutions, it has answers. But this is to determine whether you've studied and adequately prepared. This is not in order to prepare you, though. Doing one of every type of problem is, by the way, this doesn't have every type of problem on it. All right, that's another thing. Do not assume, there's just no shortcuts. Do not assume that if you do the study guide, and another thing too, someone does the study guide, they're probably doing it with their resources out and available, right? They're doing it with their resources, hopefully, you know. But you shouldn't be. You should be doing the study guide as if you're taking the final. You should be doing the study guide as if you're taking the final. All right? And after that, then get your resources out, then come see me for help or whatever, and we'll go through those problems, right? Now, I'm going to be handing out another final exam review that I'm going to do in class. So the final exam is going to have its own review packet of slides, just like a chapter, right? So after chapter 5, I'm going to be handing out another packet, and we're going to be doing, we probably can't get to all of them, but we're going to be doing a lot of those in class as we have time for, okay? Right? And the third thing, at the end of these slides, there is a list of stuff you will see on the final. All right? You know, similar to this, okay? So we're going to have that. Also, I am going to put all of this up on Canvas in the files folder. So you will find these on Canvas. Go into our course, over here in files, in here, class notes, here, you will find them. You know what? There might be a way for me to put them on the main screen. I'll tell you what. If I can find a way, yeah, I think I can. If I find a way to put them down here under final exam, see, here's the final exam weight adjustment. Right here, the final exam weight adjustment. That's all right. So the final exam weight adjustment is that entry I told you about that I'll take care of, and that will be a number of points to adjust the weight of your final exam to the weight you specify on the final. By the way, if you do not specify a weight on the final, you leave 25, 50, 75%, you leave them blank, it's going to be 25. That's the default. Okay? Because that's about what a normal final is weighed, you know, 15 to 25% in most classes. So that's going to be your default if you leave that blank. All right? So I will try to put those files here actually. So check here first. All right? That's where you'll find them. All right, all right. Put the face diaper on. And let me collect. Oh, yeah, I got something. I want to take something and give something. Okay? So I'm going to take something. And I'm going to give something. For you, I'll give something and then take something. Just pretty special. All right? All right. Good. Okay. This is the first of 2 packets you're going to get for the final. The second one I printed out. So I think it's printed out downstairs. I'll give it to you next time. This is the one. This is the one you can consider a quote unquote practice exam or study guide or something like that. All right. Okay. All right. This is where we left off last time. Oh yeah, that killed 40 minutes. 35. This is where we left off last time. Where we were at, what were we doing? It seems like a long time ago, right? Where were we doing? We were doing this. We were doing systems of equations, linear equations, you remember there's three outcomes you can have. You can have one solution, no solution, or infinitely many solutions. All right. One solution, you're going to arrive at a solution down here, at a solution. Right? No solution, you'll arrive at a contradiction. Infinitely many solutions, you'll arrive at what's called a tautology. So in these last two cases, all of your variables are going to cancel out. That's what's there in red. All your variables cancel out. You're left with an equal sign, and you make your decision by, are the things on the sides of the equal sign the same, or are they different? If they're the same, infinitely many solutions. That's a tautology. 7 equals 7 is a tautology. It's always true. 0 equals -3 is a contradiction. It is never true. So that is a no solution case. So going down here, last time, kind of lucked out, but we wound up with a solution. Let's go to this one. And I elected to do this one by substitution. We did the last one by elimination. I do not care which one you do on a problem. Right? My recommendation is to learn both because some problems are just set up for one or the other. They're just set up. Oh, one more thing I should mention. Suppose you have one that does not have this entry here. Suppose that Z was not there. Right? What would you do? How would you go about solving the problem? You would write in plus 0z. Treat that as 0 times z. That's how you would do that. All right? Okay? So, where do we start? We're doing by substitution. All right? We're going to solve for one of the variables in one of the equations. Right? All the colors on this projector are like more vivid. Tell me how that, I mean, if you got any feedback on how students like this, you know, do you like sharp colors? Do you like not? Yeah, I mean, if you got any opinions, be sure to let me know. Okay, step one. Step one. Where's that dumb thing? Why is it vibrating? Huh. Step one. You're going to solve for one of the variables in one of the equations. So solve for one of the variables in one of the equations. Now, I look for a variable in one of the equations that has a 1 or a -1 in front of it. In reality, it doesn't matter which equation or which variable you solve for. But I'm going to go for a variable that has a 1 in front of it. Because if you don't, you're going to have unnecessary fractions. Okay? So I'm going to solve for, like, look up here in equation 1. Z is a -1. So I'm going to solve for Z in equation 1. Okay? So this comes down here. Solving for Z. Z is going to be -2x plus 2y plus 3. You solve for Z in that. I'm going to call that equation 4. See what we did? Now, Jasmine may choose to solve for x in equation 2. Parker may want to do z in equation 3. It doesn't matter. I don't know. Mika Ray, she's cranky. She might want to do y in equation 3. She likes fractions. Right? Just ragging on it. Nobody likes fractions. But you can solve for any equation or any variable in any of the equations. I pick one that has a plus or minus 1 in front of it. All right? And so this is equation 4. What are we going to do with that? Step 4 or step 2. Now, notice that 4 came from equation 1. This came from equation 1. Ergo, we are going to plug 4 into equations 2 and 3. So we're going to plug 4 into 2 and 3. Now, plug means substitute. Plug means substitute. Okay? Into equations 2 and 3. Do not plug 4 back into number 1. And we did this a couple of slides ago, a couple of days ago, I don't know, a week ago, where if you solve for a variable from one of the equations, and you plug that variable back into the same equation, you're going to get a 0 equals 0 or a 5 equals 5 result. All the variables are going to cancel out. And you will incorrectly conclude that you have infinitely many solutions by that first slide that we put up. All right, that is an incorrect conclusion, but it will look like it because all the variables will have canceled out and you'll have 4 equals to 4. So don't plug that back into equation 1. Now watch. So equation 2 is going to go here, right? And that is 2. X plus y plus 3z equal minus 2. And then I'm going to plug it into equation 3. 3 is 3x minus 5y minus z equal 8. Don't forget what I told you. There's a psychological thing about dropping negative signs. So up here, you see that these negatives? Be sure down here you carried all of your negatives. So equation 2 only had the negative there. Equation 3 has negative 5y and negative z. Negatives tend to drift into positives, especially if they are a leading negative. So if I had a negative right there in front of that 3x, that would especially be something that you tend to drop as you copied it. So be aware of that. Okay. Now what I'm going to do is I have now a formula for z. I'm going to plug z in to these two. So I'm going to have x plus y plus 3 times what z equals. And that's going to equal minus 2. All right? And so now this goes here. Instead of writing z, 3z, I'm going to do 3 times what z equals. So that's going to be minus 2x. Remember what I said about leading negatives? Plus 2y plus 3. All right? Then, what do we have? On this side, 3x minus 5y minus what z equals 8. And that is the same thing. You plug the same z, exactly the same, over here. That gets rid of z. That gets rid of z. Now, we got to do some simplifying. All right? I should write up here, comma, simplify. All right? So very carefully, x plus y 3 times minus 2 minus 6x plus 6y plus 9 equals minus 2. All right. Simplify. I have x minus 5x is excuse me, x minus 6x is minus 5x. I have y plus 6y is plus 7y. And then my constant 9 goes over on the other side as a minus 9. That makes that minus 11. That is going to be equation 5. That's equation 5. Then here, 3x minus 5y plus 2x minus 2y minus 3 is 8. Three plus 2, 5x minus 5y minus 2y is minus 7y. Minus 3 goes on the other side as an 11. Does that look familiar? You see how one is just the negative of the other? Right? Now, right now, oh, this is equation 6. So step 3 is solve. You're going to solve 5 and 6. All right? Solve 5 and 6. But when you see that they're the same, here's what I would do. How would you solve 5 and 6 by substitution? You would solve for x or y in one of them and plug it into the other one. But I would just put this here. Write that as minus 5x plus 7y is minus 11. Put this dude down here. 5x minus 7y is 11. Draw a line and add. X's cancel. Those cancel. Those cancel. And those cancel. So what does that leave you with? What does that leave you with? Whoa. Oh, we have got to do something with this. That leaves you with 0 equals 0. Now, when you see that, you don't be startled. You know what you say? You say, yay, because you're done. All you have to do is interpret that. So this means infinitely many solutions. All right. Out of time. We'll pick up there next time. I will go over some more of this problem because there's some more I want to say. We're out of time. I don't want to keep anybody from getting to chapel. All right. Come see me if I can help you make corrections on your exam or help you better prepare for the final.